Here, we follow the systematic analysis table to identify the given salt. 1. Preliminary examination. A. Color. The color of the given sample is white. Therefore, the inference is copper, ferrous, and manganese cations are absent. Now, the next test is physical state. The physical state of the given sample is crystalline. Now, the next test in the preliminary examination is solubility. We add small amount of the given salt to the test tube containing water. We observe that the given salt is soluble in cold water. Now, the next test in the preliminary examination is action of heat. A small amount of the given salt is taken in a dry and clean test tube and it is gently heated with the help of a non-luminous flame of the Bunsen burner. A pungent smell of ammonia is evolved and a white sublimate is formed. Therefore, the inference is it may be a ammonium salt. Next, we move on to identification of anion. The first test is action of diluted HCl. Take a small amount of the given salt in a clean and dry test tube and then add few drops of diluted HCl. We observe that a colorless gas is evolved with brisk effervescence. Therefore, we can infer that it may be a carbonate ion. Now, we perform the confirmatory test for carbonate ion. Salt solution plus barium chloride solution. To the salt solution, we add barium chloride solution. We observe that a white precipitate is formed. When we add diluted HCl to the test tube, we observe that this precipitate is soluble. Thus, carbonate ion is confirmed. Therefore, the anion present in the given sample is carbonate ion. Next, we identify the cation present in the given salt. Now, let us perform the group separation test on the given sample. The first group test, action of diluted HCl. To the salt solution, we add diluted HCl. No precipitate is formed or white precipitate corresponding to the presence of lead is not formed. Therefore, we infer that first group cation, that is lead, is absent. Therefore, we eliminate the first group cation lead from the possibilities. Now, we test the sample for the presence of second group cation copper. The second group test, salt solution plus diluted HCl plus hydrogen sulfide gas. To the previous test tube, we add hydrogen sulfide gas. No precipitate is formed. Therefore, we infer that second group cation copper is absent. Therefore, we eliminate second group cation copper from the list. The next test is third group test. Salt solution plus ammonium chloride plus ammonium hydroxide solution. To the salt solution, we add ammonium chloride and then we add ammonium hydroxide solution. No precipitate is formed. Therefore, we can infer that third group cations are absent. Thus, we eliminate third group cations, aluminium, ferrous from the list. Now, fourth group test. Salt solution plus ammonium chloride plus ammonium hydroxide solution plus hydrogen sulfide gas. To the previous test tube, we add hydrogen sulfide gas. no precipitate is formed. Therefore, we can infer that fourth group cations are absent. Thus, we eliminate zinc and manganese cations from the list. Now, we move on to the fifth group test. Salt solution plus ammonium chloride plus ammonium hydroxide plus ammonium carbonate. To the salt solution, we add ammonium chloride, then we add ammonium hydroxide solution, and finally we add ammonium carbonate solution. No precipitate is formed. Therefore, we can infer that fifth group cations are also absent. Thus, we eliminate barium and calcium cations from the list. Now, we move on to the last group test, that is sixth group test. First, we test the salt for the presence of ammonium ion. Test for ammonium ion. Salt solution plus sodium hydroxide. To the salt solution, we add sodium hydroxide solution. We warm this mixture. A pungent smell of ammonia is formed. It may be an ammonium salt. Therefore, the inference is it may be an ammonium salt. Now, we perform the confirmation test for ammonium ion. Salt solution plus Nessler's reagent. To the salt solution, we add few drops of Nessler's reagent. A reddish-brown precipitate is formed. Thus, ammonium ion is confirmed. The given salt contains ammonium cation